Hi, this is Mr. Ward, and this is your Algebra Do Now 28.3 video key. I am the key, and I assume you know your B block. So here we go. What do we get if x is 1? What does x plus 2 times x minus 1 equal? And this is the type of thing. If you can figure this out, you're actually all set pretty much to do quadratics 4. And you should do it because it's short, it's easy, and you can check it off. This is about the zero product property, because if we say 1 plus 2, so we're replacing x with 1, and we say in the next one, x minus 1 becomes 1 minus 1. Well, 1 minus 1 is just 0, so it actually doesn't really matter that 1 plus 2 is 3. I mean, I'll go ahead and say that, but 1 minus 1 is 0, and I'm multiplying 3 times 0, so it's going to be 0. Over here, this could have been 85 trillion. It wouldn't matter because the product would be 0 because I'm multiplying times 0. Okay, so I've actually found one of the x-intercepts for this parabola. Okay, if I were to draw this parabola on a graph, I could say, okay, here's my y-axis, here's my x-axis, and I would know that when x was 1, my parabola goes through right there. Okay, so let's go ahead and deal with the other one. So if x was negative 2, we replace x with negative 2. So it becomes, instead of x plus 2, negative 2 plus 2. And then the other x becomes negative 2 as well, negative 2 minus 1. And it's nice to know that negative 2 minus 1 is negative 3. But really all that matters here is that negative 2 plus positive 2 is 0. So you get 0 times negative 3, and that's just going to be 0 because it doesn't matter what you multiply times 0. You're just going to get 0. Okay, so I can plot that negative 2 here. So there's a negative 2 and a positive 1. And then I could also go ahead and work out what the y-intercept is. It's going to be when x is 0, I'd have a 2 and a negative 1 times each other. So I'd have a y-intercept down here at negative 2. And then I'm just going to have my characteristic parabolic shape. It's going to look something like that. That was a little too jagged at the bottom. I'm going to can I undo that? No, I can't really undo that. At any rate, it's going to be a parabola. It goes up like that. I'll go ahead and not do it that way. I'll just go ahead and graph it on Desmos just so you can see what that looks like. Okay. And that's just going to be x plus 2 times x minus 1. And there it is. See? X-intercept at 1, x-intercept at negative 2. That 2 times negative 1 when x is 0 got us a negative 2 as well. It does have a vertex down here, of course, which I'll teach you how to figure out later. But this is the really important thing. These are the zeros of the factors here, and those zeros give us the zeros or the x-intercepts of the parabola. Okay, so let's go back into the do now. Okay, so here we are. So we've got those first two. Now, what if we multiply anything times 0? Well, you should probably know that anything you multiply times 0 is going to get turned into 0. The product will be 0. All right, now you've got this thing here. And we want to know what this whole thing equals if x is 9. Well, so we could go through the whole thing. You could go through this whole thing, but you might have noticed already that there was an x minus 9 in there, and you didn't even need to do all this other business. It's nice to know what those things are, but we won't need that for this problem because 9 minus 9 is 0. Doodly squat, nothing. Zilch. So the whole thing, whatever all those other things equal, is going to be 0, which tells us that this whole thing is going to have x-intercepts, it'll have an x-intercept at 9. I'll come back on that in just a second because the next question asks us what other x values would make this equal to 0. Well, I put this in here, and instead of 9, let's say I put 102 here, and each one of these got the 102 treatment. X gets to be 102 the whole way through. If X is 102, doesn't matter what these are. These are all some number, but who cares about them because this here is 0. So I copy that over and I get this times 0, and anything times 0 is 0. Okay, I'm going to do the same thing. Give this, let's give it the 19 treatment. So if X was 19, we don't care about all of these, but the one that we do care about, well, there we just passed the one that we care about. The X minus 19 will be 0, and then the whole thing is 0. So all I need to do is turn each one of these into 0. So 19 will turn, X being 19 will turn that into 0. X being 102 will turn that into 0. X being 9 turns that into 0. And X being 22 turns this into 0. All these numbers turn the others into other stuff, but who cares about all that? Because as long as one of your factors is 0, the whole thing is 0. So that's now a 0. So if X is 19, the whole thing equals 0. Okay, and then should actually be capturing all this up here. So X can be 102. X can be 19. And then what X value would make X plus 22 0? Okay, so, well, when you're adding things, opposite added to something makes the other thing go away. So let's focus in on this one. So we're going to change X into the opposite of 22, which is negative 22. And it doesn't matter what negative 22 minus 9 is. It doesn't matter what negative 22 minus 19 is. And it doesn't matter in this case what negative 22 minus 102 is, because this whole thing is getting turned into nothing by this one, because negative 22 plus 22 is 0. And so the whole thing equals 0. So one more value for this, X can be negative 22. And of course, we already know X can be 9. If we want this whole thing to be 0, these are the things that would make it 0. Let's actually go into Desmos and I'll show you what that means on a graph. On a graph, that means that we've found our X-intercepts. So I'll turn that off, turn this on. So you can't see all of them, but if I zoom out, you will. Okay, I have to zoom out a bit. So right there, 102, 0. 102 makes the whole thing equal 0. This Y means what the whole thing equals when X is 102. This Y 0 means what the whole thing equals when X is 19. And when X is 9, the whole thing equals 0. And when X is negative 22, the whole thing equals 0. These are called the X-intercepts. They are also called the zeros for hopefully obvious reasons. They make this 0, and they also make each one of these 0. They are the X-intercepts, both of these factors, but also the whole function. Zeros and X-intercepts have a couple other names. They can also be called solutions, because finding out what the X-intercept is often key to solving a quadratic equation or any polynomial. Furthermore, they get called roots because those solutions can also be thought of as the roots of squared or cubed functions. And polynomials, as you've probably noticed, involve squares or cubes, or in this case, to the 4th power, because x times x times x times x would be x to the 4th power. We'll learn more about the roots later on. You don't need to know so much about that yet, but there are 4 words for an X-intercept in a polynomial. An X-intercept, a 0 because it makes it 0, a solution because the X-intercepts are helpful in solving things, and a root for reasons we'll get into in more detail later. I hope that was helpful for this Do Now, and